Picking up where I left off last time. Welcome back. We came up with the currents, which didn't completely solve the problem. So I can now find the voltages. I have 4.2 milliamps running through a 3K resistor, so that voltage drop would be 3,000 times 0.0042, which should be about 12.6 volts. And I know the 8K and the 3K are in parallel, so the voltage drop across the 3K is the same as the 8K. Now I could have used 8,000 times 1.6, but I have a greater error because I rounded more. So I know the 12.6 is closer to the actual value. That's something I did subtly. If you are in circuits, then, or if you're familiar with circuits, you know that parallel components have the same voltage drop. The other voltage drop in the circuit is across my 2K resistor. It's got 5.7, so that's 2,000 times 0.0057, which, if I did it in my head and I realized that the K and the milli cancel, is 2 times 5.7 or 11.4. Why did that show up? 11, I fat fingered a key. Sorry. 11.4 volts. So what I gave you initially was 19.2 and 4.8, and what you see when we solve the circuit is we got 12.6 and 11.4. So clearly there's a fault in the circuit based on the values I gave you. Alrighty. Okay, I want to do this another way, and it won't involve Scilab, so I can minimize my Scilab. And I want to build the circuit a different way. Okay, there's the circuit I want to build. And I want to build it in LT Spice. So I've got my little Spice window open. Now, Spice is free software. And it came up by default with a new circuit. So I can close. File, close, and then if I close, your splash window will be a little different than that if it's Windows, but you'll have something. Just like a Windows program, I can get a new schematic. So File, New, and then I can place components. So I'm going to use the Component tab. Here's my resistor. I'm going to use the label, I'm going to use the ground, I'm going to use the wire. When you first start doing this, you'll make some mistakes. So if you put something on your schematic you later on don't want, or if you're trying to follow me and I do something that I don't tell you about, then the scissors here is your friend. Anytime you turn on something up here, generally you have to turn it off, which is either right mouse click or hit your escape key on your keyboard. We're also going to do the run, and we're going to do the simulate, which we got to edit simulation command at some point. So we want to build the circuit that we've been talking about all morning. So I'm going to click on component, and this box is going to open. I'm going to slide all the way to the right in the last two because everything's in alphabetical order. I'm looking for a voltage source, and here's my voltage source. And in Spice you can set it up to be DC, AC, whatever you want. We're going to use it as a DC source, but we've got it. And then it's following my mouse around. Now I haven't clicked yet, it's just following my mouse around, but when I click, it plants it in my circuit, and now it's wanting to plant voltage 2. This is where I told you you either have to hit the right mouse button or the escape key to go back to a cursor. So we want one voltage source. We want 3 resistors. And so I clicked on the resistor icon and I dragged it down. And what you notice is my resistors in my handout are horizontal and these are vertical. In a lot of programs, Control R is your rotate. That's a shortcut for rotate apart. So I'm going to rotate this one. It's going to follow my mouse around. I'm going to click to put it where I want it. I need 2 of them, one above the other. So I'm going to click that one. And then I need a 3rd resistor to make it look like what we had in the first drawing. So I'm going to click there. I don't need a 4th one, so I'm going to hit the escape key. The next thing I'm going to do, and you can do these in any order you want, you got to wind up with the end product you want. So I do things a certain way. It's going to make more sense to you probably do it different ways once you gain experience. Feel free to do any way you want to. It doesn't really matter until you try and do the analysis. It's got to be right by the end. But getting there, multiple paths. I like to do wires once I get all my parts in. And so what I did is I clicked on wire and this crosshair popped up. Let me escape. I'm going to click on the wire and this crosshair pops up. Now I'm basically going to connect these boxes together. And so when I hover over the box and click, now I can go vertically or I can go horizontally. Okay, so I'm going to go vertically here until I see my line intersecting with the box to the right that I want, and then I'm going to click, and that allows me to turn corners. And when I get to the end box, I click again and I have a line. For this one, I'm going to click, and I'm going to go left slightly, click, and then I'm going to go up until I'm back in that other wire, and it will put a node in there for me. These two I just joined together. This one I go over halfway or so. Doesn't really matter. And I click, and there it is. This one I got to go all the way around to the minus side of my voltage source. So I've got to make several clicks to get there, several turns to get there. Now something you notice is my schematic just went off my screen because it's wanting me to start a wire there. So I've got to escape out of wire, and this brings up a good point. Anytime you lose your schematic on your screen, hit your space bar. Okay, I have shortened my window, so what it's doing is it is centering it on my window, so I actually have to come down a little bit with it. And then I'm going to have to move it over slightly. Let's see, can I do that? There we go. I lost a little bit of my Word document, but that's okay. Alright, I'm leaving these values here just so we can see how spice analysis compares with what we saw manually. The other thing that you have to have in circuit analysis using software is a ground. And a ground basically assigns a wire to 0 or node 0. I like to put them underneath the minus of my power supply. You can put a ground anywhere you want in the circuit, anywhere that makes sense to you, and even if it doesn't make sense to you, the software won't care, it will solve it. But I just made this wire from the minus side of my power supply all the way around to this resistor, wire 0. And so this is my reference. So any voltage measurements will be referenced to my 0 or my ground. The other thing I'm going to do is I'm going to go in here and I'm going to label these other 2 wires. This wire is an equal potential point, which means it has the same voltage everywhere on it between these 2 resistors and this resistor, and I want to call that wire number 2. So I click on the net name, type a 2, and click OK, and then you see it's following my mouse around. I've got to get that little blue box on that wire somewhere, doesn't matter where. Click there, and now it's a 2. Now it wants me to label it multiple times. Gotta escape. 1. Okay. And I'll make my wire number 1 over here. Labeling your nodes will make your analysis a little easier. It'll be a little easier to interpret. Okay, my resistor values are 3K, 8K, and 2K. And then if you notice on the handout or my original document, I had these changed too. And I changed the actual name of these so I can pick it out of the analysis better as well. It's not a detail you have to do, but you have to keep it straight. Because if you misinterpret your results and you write down the wrong values, then it's not right. Okay, so to change the resistance value, I hover over the actual resistor. It turns into a hand. I right mouse click, and then I can type in my resistance. And this one is a 3K. Scilab recognizes K as 1,000, so it recognizes metric or engineering prefixes. And when you're staying basic, you don't have to worry about tolerance or power rating. You just put in values to start with. This one is an 8K. And this one is a 2K. I'm going to set the voltage the same way. I'm going to hover over the actual symbol. Right mouse click, it's asking me for a DC voltage, and it's 24 volts. I don't have to worry about an internal resistance. If you want to add one, you can. If you want to make it an AC, that was the advanced tab. An AC, sine wave, all those other options are there. But for DC, it's just type in one thing. On the handout, I called this R3K instead of R1. So now instead of hovering over the part, I got to hover over the box or the name R1. Right mouse click, and now I can make this R3K. And I'm basically naming this resistor that name. And I can change V1 and make it a different name if I want to. And this one is R8K. And this one is R2K. Okay? So I renamed my resistors. And you'll see when we do the analysis why. It makes it easier to interpret the results. It takes a little bit extra time and effort up front, but it's worth it in the end. Okay, now we want to let Spice solve this circuit for us because it's the same information I gave you. So I have to go in and I have to do simulate edit command. Now this is very powerful software, and it would take somebody into graduate school as far as the analysis it is capable of doing. We are starting out in DC circuits. We start out pretty simply. We just want to know the DC operating point, and so all we have to do is click on that tab, click OK. We've got this dot op down here, and what you'll see is my dot op is following my mouse. You've got to click it somewhere in your circuit. You don't have to escape on this one because it's just one time, and now we are ready. So this is telling me I want to do DC analysis on this circuit. You can do DC analysis, you can do AC analysis, you can do transient analysis, frequency response, all sorts of stuff. Okay, that's for later on as you get into the field. All that stuff opens up for you. So now I'm just doing DC analysis, and there's this little running person here, or I can do simulate run. Like any Windows program, it's multiple places. Alrighty, so now I get some results. I'm going to make that box very small, and I'm going to go way down here with it. Okay, how do I interpret my results? V is voltage. 1 means node 1, which we labeled, to 0 by default. So any voltage value is from 1 to 0. Its value is 24 volts. So I've got 24 volts measured across my voltage source. If I put a voltmeter 1 to 0, I'd get 24. That's what we would expect. From wire number 2, or node 2 to 0, I get 11.5. Now what you notice is we calculated it to be 11.4. And what Spice told us is it's really closer to 11.5. If I want to know the voltage drop from 1 to 2, I have to do the subtraction. I have to do 24 minus 11.5, and I get 12.5. So my Spice analysis is 12.5 V, and down here Spice is 11.5 V. Okay, just so we know, that's close enough. That's within our rounding error, so that's great. Currents. What is the current through my 2K resistor? And that's why I relabeled that as R2K. So I know, hey, this is my 2K resistor. My current is 5.7 milliamps. Well, that's what we calculated. The current through my 8K is 1.6 milliamps. Well, hey, that's what we calculated. And the current through my 3K resistor is 4.2, which is what we calculated. And this actually is the current coming out of my voltage source. It's actually the same as the current flowing through the 2K, 5.6. So that gives us a complete analysis of that circuit. Okay, so we get the same values that we got manually, but we got it in Spice. And all we did was build the circuit, connect the circuit, take a little time to make sure we could interpret the results right, and then we did it. Okay, so now I'm going to close this, and you can copy and paste these into documents. So I can copy and paste. If you want your analysis somewhere to print out. Universal shortcuts, Control C for copy, Control V for paste, and I can put that there. So I've got my Spice results right with my manual results. So I've now done it both ways. Because when I close this box, I lose it. I can always rerun it and get it back, but I've lost it for now. Okay, so if I go back to my original Word document, Taste of Industry, and I scroll to the bottom, there's my Kirchhoff's laws, and there's my Scilab simultaneous equations. TI-84 can do DC problems but not an AC one. Scilab, you can actually do AC problems. Compare the obtained values to given values. Where's the single fault? So what we want to do now is we want to go in and we want to troubleshoot. Okay, a troubleshooting tip. We're looking for one single point of failure. And troubleshooting tips. Troubleshooting is usually done with a voltmeter. You're never going to measure current. Never say never. You will very seldom measure current. You will mostly do your troubleshooting with a voltmeter. Open components change voltage values. If everything is sequenced, then the open component will drop the entire source voltage. It's a good rule of thumb. It's a good one to put back in your memory bank. Shorted components will show a near zero voltage drop where there should be one. Okay. So our normal conditions for this, if I measure from 1 to 0, is 24 volts. If I measure from 2 to 0, it was 11.5, as you recall. If I calculate or I do the 24 minus 11.5, I get 12.5. And that's my normal condition. 24, 4.8, 19.2 is what I gave you. So what fault in the circuit would cause those values? And basically what I've done is I've given you 6 blanks here, so you can go back and you can systematically open and short every component. Okay, so if I go back to Spice, and let's say I want to short the 2K resistor. Okay, now if I draw a line between this point and this point, it's changing scales because it'll let you do voltage in real time across there. Once you do an analysis, it'll let you do a voltage. So if I click here with the probe, it's showing me what the voltage is at that point. I can probably click and hold and go across there, and it will do the calculation for me. Some spices do it, some you have to do it yourself. So, and it doesn't work in AC. There's something about it. In DC it works pretty well. Okay, so that's why that probe is changing. And if I go through a component, oftentimes it turns into an ammeter. It wants to give me current, but not in this case. Okay, let's get back on task. I want to short the 2K resistor. If I draw a line, if I go up here to line, I can draw a line between this side of my 2K to this side of my 2K. What Spice will interpret that is as I'm taking my node 0 here that's grounded, and I am connecting it to 2. Well, 2 will go away, and my analysis will look funny. So if you want to short a component, and you want it to respect your 1s and 2s, your node numbers, then you have to go in and you have to place a resistance, but a very small resistance. So I'm going to Control R it, put it right there, and then I'm going to draw a line. And my value, got to assign a value. If you don't assign a value, your analysis won't work, is 0.0001. All right, that's 0.1 milliohms. And now if I simulate, because I'm already set up for DC simulation, this would be a shorted 2K. So I get 24 volts from 1 to 2, or 1 to 0. And I get 1.1 times 10 to the minus 6 between 2 and 0. So that's effectively a 0. And then my currents are there. So I get almost all my 24 volts across from 1 to 2. This is effectively a 0. So if I go back to my table, and I remember that, I get 24 volts here. My 2 to 0 measured is going to be really close to 0 volts. My 1 to 2 calculated is 24 volts. My condition is a shorted 2K. What happens if I open the 2K? Well, I'm glad you asked. Okay, anytime you put in a fault condition, the first thing you should do is remove it. Remember, scissors are your friend. So there you go. And then escape out of your scissors, otherwise you'll click and something will disappear that you didn't mean to. Okay, so now if I open my 2K, oh, I want my scissors back. I'm going to open my 2K. Opening components is much easier because all I have to do is delete them and then hit the run button. And it tells me my voltage at 1 is 24, my voltage at 2 is 24, and then everything else, all my currents are obviously a 0. So then I can go in here and say, okay, so on open 2K, I get 24. I get 24. So the difference between 1 to 2 is actually a 0. I would measure 0 volts across that parallel combination. And now I have an open 2K. Okay. Still haven't found the values that match up in the table. So, close. Now, what if I do edit undo? Hey, I edit undo and my deleted part came back. That's handy to know. I was hoping it would. Let's open the 3K and do the analysis. And it tells me my V1 is 24, my V2 is 4. So my difference between V1 and V2 is 19.2. 24, 4.8, 19.2. And now we know we have an open 3K. One thing I want to mention is, if you short, got to close the analysis window before I can edit undo. If you short the 8K and you short the 3K, you're essentially shorting both. So you will get the same results for a shorted 3K as you do for a shorted 8K, but you'll know where to look for the short in the actual circuit. And so this is the analysis, and this software makes it simple. I mean, to do it by hand, you would have to essentially recalculate all your circuit values. But you're not going to normally recalculate all your circuit values for every fault condition, but you would calculate your values for to figure out what normal should be, in which case you could do that by hand like we did there. So anyway, this is a good stopping point for video number 2, and I thank you for watching. And video number 3 is next.